let's take a look at quadratic functions. So a function in which the greatest power of the variable is 2. So function equations where x squared is the highest exponent. They can be written in the form ax squared plus bx plus c. Sometimes there's not this part, sometimes there's not this part, but this is the general form that it can be in, and specifically it has to have that x squared, where a is not equal to 0, because then you wouldn't have x squared. The graph of a quadratic function is called a parabola, in case you hear that term. It is U-shaped. If the coefficient is positive, it is a U-shaped upward. If it is negative, it is facing downward. So you can see we have a positive one here compared to the negative version here. Same thing, just opposite. So to graph a quadratic function, we're going to make a table of values, plot the ordered pairs, and connect the points with a smooth curve, or as smooth as we can do. Every single time, we are just going to plug it in as -2, -1, 0, 1, and 2, and we'll see what fits on our graph. So right now we're plugging in here 6x squared. So 6 times -2 squared. So -2 squared is +4. 4 times 6 is 24. So -2, 24. Over here, plugging in 6 times -1 squared. So -1 squared is 1 times 6 is 6. So we get the ordered pair, -1, 6. Plugging in 0, 6 times 0 squared is just 0. So 0, 0. Plugging in 1, 6 times 1 squared. 1 squared is 1 times 6 is 6. So we get the ordered pair, 1, 6. And then last one we're plugging in is 2. 6 times 2 squared. 2 squared is 4. 4 times 6 is 24. So we get 2, 24. And you should see kind of a pattern here, right? It's kind of symmetrical. So I know I'm not going to fit the ones with 24, but I should be able to fit the other one. So I'm going to plot -1, 6, 0, 0, and +1, 6. So I'm not going to be able to do this perfectly. That wasn't beautiful, but it should make a U shape going up because it is a positive x squared. Let's try another. Y equals -x squared plus 4. Plugging in -2, -1, 0, 1, and 2. So, negative on the outside, because this is multiplication times the exponent. Exponent comes first. -2 squared. I'm not eliminating those two. We square it, then we apply that negative on the outside, plus 4. So this becomes -2 squared is +4, but then we apply the negative. So it's -4 plus 4, which is 0. So our ordered pair is -2, 0. Let's plug in -1. So we've got -1 squared plus 4. -1 squared is 1. Apply the negative. We get -1 plus 4, which is +3. So the ordered pair is -1, +3. Over here, we're plugging in 0, so -0 squared plus 4. Well, you can't have a -0, so this just is 0 plus 4, which is 4. So we get the ordered pair, 0, 4. Plugging in 1. -1 squared plus 4. 1 squared is 1. Apply apply the negative, we get -1 plus 4, which is +3. So we get 1, 3. I'm plugging in 2. -2 squared plus 4. 2 squared is 4. Apply the negative, so -4 plus 4 is 0. So 2, 0. Let's go ahead and plot. So we've got -2, 0. We've got -1, +3. We've got 0, 4. +1, +3, 2, 0. And you should see that U shape. This time it's going down because we had a -x squared. Over here, the origin, or the vertex was at the origin because there was nothing added or subtracted. This one, our vertex is at +4 because we were adding +4. Let's do one more and then we'll get into some word problems. Y equals 3x squared minus 4. So, again, we are going to plug in -2, -1, 0, 1, and 2. So 3 times -2 squared minus 4. So -2 squared is 4. 4 times 3 is 12, minus 4 is 8. So the ordered pair is -2, 8. Plugging in -1, so we get 3 times -1 squared minus 4. -1 squared is 1, times 3 is 3, so 3 minus 4 is -1. So -1, -1. Plugging in 0, 3 times 0 squared minus 4 is just 0 minus 4, so -4. So our ordered pair is 0, -4. Plugging in 1, 3 times 1 squared minus 4. 1 squared is 1, times 3 is 3. 3 minus 4 is -1. So we get 1, -1. And last one, 3 times 2 squared minus 4 equals 2 squared is 4. 4 times 3 is 12. Minus 4 is 8. Again, we should see that pattern. Let's go ahead and plot that. We've got -2, +8. Let's have this go up by 1, 2, 3, 4, 5, since it's 5. Actually, no, we can leave it as is. We just won't graph the 8s. Nah, I want to. Let's have this go up by 2, 4, 6, 8. Okay. So, I've got -2, +8. Let's have these go by 2, 4, 6, 8, 2. 2, 4, 6, 8. So -2, +8. -1, -1 is going to be like right here. Then we've got 0, -4 is right here. And then 1, -1. And last but not least, 2, +8. So it looks something like that. Okay, let's look at some word problems. The outdoor observation deck of the Space Needle in Seattle, Washington is 520 feet above ground level. Use the graph to estimate how far you could see from the observation deck. So, the observation deck is 520 feet above ground level. So I'm going to find, if this is 500, 520 is going to be somewhere around here. So it hits kind of around here. Let's say maybe it's like 27 miles, something around that. Okay, let's make our own with the word problem. So the function a equals 0.2 v squared models the acceleration of a carnival ride, where a is the acceleration toward the center of the ride in meters per second every second, and v is the velocity in meters per second. Graph this function, then use your graph to estimate the velocity of the ride at an acceleration of 1 meter per second every second. So we are looking at A is acceleration, and here V is our velocity. Okay, so we don't have a table here. We can fill out the table on our own with values that make sense. So, let's plug in different x values, 1, 2, 3, 4, and so on. So, 0.2 times 1 squared is equal to 0.2 times 1, which is just 0.2. So, our ordered pair is 1, 0.2. Okay, let's plug in 2. 0.2 times 2 squared equals, well, 2 squared is 4. 4 times 0.2 is 0.8. So it's 2, ordered pair is 2, 0.8. Let's plug in 3. 0.2 times 3 squared equals, 3 squared is 9. 9 times 0.2 is 1.8. So our ordered pair is 3, 1.8. And that's pretty much taking us up the graph that we have here. So let's just kind of from here draw a little graph. Now we are looking at this and saying, okay, what can we estimate? Use your graph to estimate the velocity of the ride at an acceleration of 1 meter per second. So we're looking at where 1 meter per second is, because that's the acceleration. We want to know what the velocity would be. That hits somewhere around 2 something, maybe about 2.2 meters per second. Somewhere around that. All right, the last one that we're going to look at is the word problem here. The function h equals negative 16d squared plus 25t plus 5 can be used to represent the height h in feet of a juggler's ball after t seconds of being tossed in the air by a juggler that is 5 feet tall. Graph the function. Use your graph to estimate the height of a juggler's ball that has been in the air for 1.5 seconds. So let's first plug in 0. H equals negative 16 times 0 squared plus 25 times 0 plus 5. Well, that's going to be 0 plus 0 plus 5. So our ordered pair would be 0, 5. Then if I plug in 1, negative 16 times 1 squared plus 25 times 1 plus 5. So negative 16 times 1 is negative 16, plus 25 is positive 9, plus 5 is 14. So we get 1, 14. And then plugging in 2, we get h equals negative 16 times 2 squared plus 25 times 2 plus 5. So negative 16 times 4 is negative 64, plus 25 times 2, so plus 50, equals negative 14, plus 5 equals negative 9. So our ordered pair is 2, negative 9. So it's going to be something like down here. So we don't know exactly how this graph's going to look. It's kind of weird looking, but we get something like this. That was kind of bad. But this one's kind of hard to draw. But at 2, we're at negative 9, which means at 1.5, we're going to be somewhere up here. Maybe around here. Maybe we can say at 1.5, it's going to be about 6 feet. If you want to double check, you could also plug in 1.5 into your equation to see where it would fall.